Okay, now let's see class 11 limits and derivatives. Okay, now we all have learned to find a value of a function at any point x. Okay, uh, to find the value of a function at any point at any point on x. Okay, that is example. If you say uh, we'll take a function that is let f of x is equal to let it be some x plus 1. Okay, this is a function. Okay, to find the value of this function at a point that is x is equal to 2, then we write it as f of 2 is equal to 2 plus 1, which is equal to 3. Okay, now again if it is at a point of x is equal to 3, at a point 3, then we write this at f of 3 and 3 plus 1, which is equal to 4. So this is the value of a function at a point x is equal to 2 and x is equal to 3. Okay, this is how we find the value of a function at a particular point. Now in the same way, limit of a function is the value of the function. Okay, limit of the function f of x is the value of the function when x is not equal to 2, it's moving or approaching to 2. Okay, that we write as x. This is the symbol of writing x is moving towards or approaching towards or tending towards 2. Okay, now when it is moving or approaching towards 2, it is coming closer and closer to 2. At that point, what is the function's value? That is its limit. Okay, now if we say, let's take the same function. Okay, f of x is equal to x plus 1. Okay, now let this be the function, and the limit of this function as x is not equal to 0, x is moving towards 2 or approaching towards 2. Okay, now if we take the number line, and if this is 2, okay, this is number line, and this is negative infinity, and this is positive infinity. Okay, this is number line, and this is 2, and x is approaching to 2. Now x can be approached from both sides towards 2. Okay, from the right hand side, from the left hand side, from the positive side and from the negative side. Okay, so we write it at now if x is approaching to 2 from both sides, as it is moving towards 2, it will have different values at different points. Okay, so the value of the function at this particular point before reaching, or even when it is close to 2, will have a value. That value of the function is its limit. That value of the function is its limit. Okay, like for a if it is, if you say x is moving towards 2 from the left hand side, okay, from this side, and it is somewhere here, maybe it's a 1.95 here. So the value of the function at this point, when x is moving approaching to 2, at this point it will be at 1.95. okay, at x is equal to 1.95, the function will be f of 1.95, which is equal to we'll take this function. Okay, x plus 1, 1.95 plus 1, which will be 2.95. okay, when x was equal to 2, it was 3. The function's value was 3. When it is equal to 2, the function's value was 3. Okay, when it's here, when x was 2, the function was f of x was 3. The value of the function was 3. Now when it's approaching to 2, and when it is 1.95, its value is 2.95. This is also approaching to 3. Okay, this is also approaching to 3. And as x is moving towards to more closer and closer, the value of the function also is moving closer and closer to 3. Now when it is 1.95, when the value of x is 1.95, the limit of the function is 2.95. This is its limit. It will not go beyond that. Okay, and when it's moving again towards 2, when x is moving again towards 2, when it's 1.99, you say, then when x is equal to 1.99, then the function will be 1.99 plus 1, which will be 2.99. Okay, this is the limit of the function when x is 1.99. It will not go beyond this. This is the limit. Okay, and this is also approaching, and the same way when x is approaching closer and closer to 2, and almost it becomes 2, we can assume that it is becoming 2 because it will be, x will be like 1.999999, which is almost 2. We can assume this to be 2. Okay, then the limit of the function also becomes 2.999999, which is almost 3. Okay, this is from when it moves from the left hand side. The same way when it moves from the right hand side, x is moving from the right hand side. For example, if this is 2.05, when x is at 2.05, the function will be f of 2.05, which is equal to 2.05 plus 1, which is equal to 3.05. Okay, so at x is equal to 2.5, the value of the function will be 3.5. This is its limit. It will not go beyond that, no, below that. Okay, not come closer to 3. Now as it keeps on moving, if it's 2.01, this is 2.01, then the value of the function will be 3.01. This will be its limit when x is 2.01. Okay, not beyond this, not below this. Now in the same way, when x is equal to 3.00000001, the function will be, the value or the limit of this, its value will be 3.00000, and so on up to 1, which is almost becoming 3. So when x is 2 point, when x is approaching to 2 and it's almost very close, then we can assume that this value to be 2. Okay, so the limit of this, of the value of the function also will be, we can assume it to be 3, because it is approaching, since this is approaching to 2, the value of the function also will be approaching to 3, and we are assuming this to be 2, so we can assume this value also to be 3. The function, the limit of the function also to be 3. Okay, now if say this is 2, the value x, this is the point where x is 2 and x is approaching from the right side to 2 and from the left side towards 2. Okay, now this limit is called the left hand limit. Okay, so to find the limit from the left hand side, we write it as limit of the function f of x. Okay, now f of x is equal to x plus 1. Now this is defined for the whole number line. Okay, from infinity to minus infinity, this function. Now limit f of x, limit of f of x when x is approaching from the left side, we write it as x approaching 2. X is approaching 2 from the left side. Okay, we write it as 2 a dash here, or 2 minus. This indicates that this is approaching from the left side. In the same way, when it's approaching from the right side, this is called as the right hand limit. Limit of the function f of x when x is approaching 2 from the right side, we write it as 2 plus. Okay, now so limit of the function, what is the function? It's x plus 1, as x is approaching 2 from the negative side, which is equal to, so we are assuming it to be 2 because it is approaching and coming very close to 2, so that it becomes, we can assume that it to be 2. So we put 2 plus 1, which is equal to 3. And the same way, when x is approaching 2 from the right side, it almost comes very close that we can assume that to be 2. Okay, so limit x plus 1 as x is approaching 2 from the positive side, it's very close that it almost becomes 2. So we can write 2 plus 1 is equal to 3. Now you see the left hand limit and the right hand limit both are equal. When this both the left hand limit and the right hand limit are equal, we can say that when LHL is equal to RHL, we can say that the limit of the function exists at this point. Okay, so now you see, since this function is defined for this whole number line, we can see that showing the left hand limit and the right hand limit separately is not required. Okay, because both values are same for this function, because the function is same for both. So same values, you'll be putting the same values in the function. So you can see, so you can write this as c limit of the function as x is approaching 2 from the negative side is equal to the limit of the function as x is approaching 2 from the positive side. Okay, then we can write this as limit f of x as x is approaching 2. Now this indicates, when there is no symbol here like this dash or the negative or the positive, this indicates that x is approaching from both sides. Okay, x is approaching 2 from the both sides, this indicates. Now when you separately write negative or the dash here, 2 negative or 2 dash, it indicates that it is approaching from the left hand side, and if you write positive, it indicates that the value is approaching from the right hand side. Okay, now so this is how you can you calculate the limit of a function. Okay, now we'll do a few questions and see. Now in the exercise 1.1, so not exercise 13.1, I think we'll do the first question. That is first question is evaluate the limits. Okay, find the limits of the function. That is limit of x plus 3 when x is approaching 3. Okay, now if you see, if you take the number line, this is 3 and x is approaching 3 from both sides. Okay, now as it coming very close to 3 from both sides, we can assume that both the right hand limit and the left hand limit, we can assume it has to be 3, because it will be 2.9999 something. Okay, 2.999 when it is approaching from the left hand side, the limit will be almost 2.99, so which can be assumed as 3. Okay, and when it is approaching from the right hand side, it will be 3.00001, very close to 3 but not 3. Okay, it's because this is approaching to 3. Okay, it's not equal to 3, it's approaching to 3, so we can assume that it's almost 3. Okay, so putting this value in the function, so now limit of the function, that is x plus 3 as x is approaching 3. Now we're not mentioning any symbol here, negative or positive. Okay, now this indicates that this is approaching from both sides. Now as x is approaching 3, the limit of the function will be 3 plus 3, which is equal to 6. Okay, now this is the limit of the function when x is approaching 3. That's it.